Characteristics of a sound wave. A sound wave can be described by three basic qualities, that is, its frequency, amplitude, and speed. The number of times the wavelength occurs in 1 second is called frequency. It is measured in kilohertz or cycles per second. The faster the sound source vibrates, the higher the frequency. Higher frequencies are interpreted as a higher pitch. For example, when you sing in a high-pitched voice, you are forcing your vocal cords to vibrate quickly. Thus, a high-pitched sound corresponds to more number of compressions and rarefactions passing a fixed point per unit time. Objects of different sizes and conditions vibrate at different frequencies to produce sounds of different pitch. It is usually represented by a Greek letter nu. Its SI unit is Hertz. We know that compressions are the regions where particles are crowded together and represented by the upper portion of the curve. The peak represents the region of maximum compression. Thus, compressions are regions where density as well as pressure is high. Rarefactions are the regions of low pressure where particles are spread apart and are represented by the valley, that is, the lower portion of the curve. A peak is called the crest and a valley is called the trough of a wave. The distance between two consecutive compressions or two consecutive rarefactions is called the wavelength. The wavelength is usually represented by a Greek letter lambda. Its SI unit is meter, m. The time taken by two consecutive compressions or rarefactions to cross a fixed point is called the time period of the wave. It is represented by the symbol t. Its SI unit is second. Frequency and time period are related as nu is equal to 1 upon t. The strength or power of a wave signal is called its amplitude, or the height of the wave when viewed as a graph is the amplitude. The loudness or softness of a sound is determined basically by its amplitude. The amplitude of the sound wave depends upon the force with which an object is made to vibrate. Speed. The speed of sound is defined as the distance with which a point on a wave, such as a compression or a rarefaction, travels per unit time. We know that speed, u is equal to distance upon time, which is equal to lambda upon t. Here, lambda is the wavelength of the sound wave. It is the distance travelled by the sound wave in one time period of the wave. Thus, u is equal to lambda into nu. That is, speed is equal to wavelength into frequency.
For more such videos on all subjects, practice questions and a lot more, download iPrep and learn unlimited.